Hello everyone, I am Sasa Dhungana and I, along with my teammate Bibek Adhikari, will be presenting our data mining project titled A Comparative Analysis of Academic and Social Networks via an Interactive Dashboard. In this part, I will give you an overview of our project, its motivation, datasets, methods, and findings. Bibek will then show you the live dashboard we built to demonstrate our analysis. In this project, we explore two very different real world networks, an academic citation network and a social network for developers. These networks may seem unrelated, but both exhibit patterns of connectivity and influence. Our goal was to analyze their structure, compare them side by side, and apply machine learning to classify nodes based on their features. We set out to do four main things. First, understand how academic and social networks differ in structure. Second, visualize and analyze them using social network analysis techniques. Third, classify nodes using relevant features like content or connectivity. And finally, present everything through a streamlit dashboard for interactive exploration. We used two datasets, the Cora citation network, where nodes represent research papers and edges represent citation links. Each paper is labeled with one of seven research topics, and the GitHub developer network, where nodes are developers and edges are mutual followers. Each developer is labeled as either a web developer or a machine learning developer. We used network X to construct both networks. The Cura network was modeled as a directed graph since citations flow one way, and the GitHub network was modeled as undirected because follower relationships are mutual. We also cleaned and standardized the data so it could be used for machine learning and visualizations. We applied common social network analysis techniques on both graphs. Centrality measures like degree, page rank, and betweenness helped us identify the most influential nodes. We used the Low-Vein algorithm for community detection and K-core decomposition to isolate the densest part of the network, what we call the structural core. These techniques gave us insights into the internal organizations of each network. We then perform node classification but use different approaches for each network. For Cura, we used the text content of the papers, vectorized using TF-IDF, and trained classifiers like logistic regression and SGD. For GitHub, we used graph structure features only like degree, page rank, and community ID, and trained random forest and gradient boosting models. Our results were promising. For Cora, we achieved about 85% accuracy using text features. For GitHub, we got about 80% accuracy using only graph features, no text at all. One major insight was that in GitHub, a developer's position in the network strongly reflects the technical role. We observed that influence means different things in different networks. In Cora, in the most influential papers are those that are cited frequently. In GitHub, the influential developers can be popular hubs or bridges connecting different communities. Both networks also followed a power law distribution, meaning a few nodes dominate in terms of connection. There are several areas for future improvement. For GitHub, we can combine graph structure with actual profile data to improve classification. We could also add a temporal analysis to see how networks evolve over time, and even look for cross network links like developers who are also academic authors. Now let's see it in action. That concludes the overall portion. Now I'll hand it over to Bibek, who will walk you through the interactive dashboard we developed to analyze and compare both networks in real time. Thank you.
Hello everyone, I am Bibek. Thank you, Sasa. And now I will walk you through our interactive dashboard where all of this analysis comes together. So, as you can see, we have built a Streamlit app with a clean tabbed layout, one for the Cora citation network and another for the GitHub developer social network. So let's begin. We have various sidebar like analysis views such as overview, centrality and connectivity, community deep dive, K-code decomposition, and model comparison. So let's begin with the Cora dataset for overview. Here we get some basic statistics and visualization of each network. For example, the Cora network is smaller with 2708 nodes and 5427 total edges. On the other hand, our GitHub has larger dataset with over 37,000 developers and almost 22 lakhs 90,000 edges. We also see that the both networks have lower density and follow a power law distribution in node degrees. That means most nodes have fewer connections and only a few nodes are extremely well connected. Now let's move to the centrality and connectivity tab. In this Quora network, we use in degree centrality to find the most cited paper and page rank to find the most prestigious one. In the GitHub, we look at degree and betweenness centrality. Here, high degree nodes are like celebrity developers, while high betweenness node act as a bridge between communities. We can interact with these graphs and tables. We have used Plotify for dynamic graphs and hover info. So as you can see, the nodes here display the network of top 200 nodes by degree. So here we can see paper ID, subject, degree, and community. So for GitHub, we can view centrality correlation, and here's the graph. So about the interactive network graph, so we have for each user we have user ID, dev type means web or machine learning, degree, and community. So let's deep so let's go to community deep dive. We use the Lovenian algorithm to detect communities in both networks. In Quora, these communities match research subject really well, like neural papers, forming a tighter cluster. So as you can see, community leaders, most central members here, we have a degree of 3000 and betweenness of 0.024. So here we can see the most papers are from web. Sorry, for GitHub, the most dev type is web, whereas machine learning covers only 7%. So for research paper, uh, we have a total share of network of 15% and a composition. So you can see genetic algorithms, neural networks, reinforcement learning, case-based theory, and probabilistic methods. So here are the list. So let's go to K-core decomposition. Here, this lets us filter the network by core level. As we increase the K value, we see only the most tightly connected nodes remain. In Quora, these are the foundational papers with many mutual citations. So as you can see, we can vary the K number. So we have a nodes in 3 core 1227 and edges in 3 core 3198. So you can see the distribution of core numbers as follows. So for the GitHub, we find a stable inner circle of developers who are highly connected to each other. So and the number is greater than that of the research paper dataset. So here core numbers and count can be visualized. So at last, let's look at modal comparison. This is where we showcase our machine learning results. For Quora, we use TFID text features vector with models like logistic regression and SCD. We reach around 85% of accuracy in predicting paper subjects. So as you can see, almost 80%, 78.74, and for SCD classifier we got 74.74. So here is the confusion matrix, and here are the top words per subject. So you can see case-based word, and now we can, so for each model we can inspect the confusion matrix and SCD classification. So for next, the GitHub, we use graph features like degree, page rank, betweenness, and community ID. With models like random forest, we achieved about 80% of accuracy in predicting whether a developer is ML or is like related to web or ML. We also display feature importance and top predictive terms or matrices used by the model. So you can see for each model, we have confusion matrix and the community feature, degree, page rank, and betweenness. For this, gradient boosting has a promising result of 82%. So in summary, the dashboard is a unified platform that helps us explore, analyze, and compare two very different networks. It combines interactive visualizations with machine learning all in one place. So at last, thank you for watching our demo. We hope you enjoyed our walkthrough and we're happy to answer any questions.